Okay, we're rolling. And we are picking it up at example 3 of 7.2. And oh, I said we were doing algebra? Okay, I lied. We're doing some algebra. We're going to do some graphing too. Okay, you just did a whole unit of graphing. We just tested you on it and everything. And what do you think? How do you feel? How do you want to graph that first one? The y, sorry, let me say that again. No, I'm right. I was right the first time. The y-intercept is super easy to find in that first equation, right? Because if x is 0, you get 3y equals 3 and y equals 1. So I have a point that I can put on here. Hang on, I don't think my pin's even on. There we go. I have the point when x is 0, y is 1. So there's 0 over 1 up. There's the first part. And what's the next? See, the problem with doing the x-intercept is I'm going to get 3 halves. I don't want to graph something that's a half. So can you think of a point that would work besides 0, 1 that I could graph this with? The other alternative is, if you don't want to find a point, we could rearrange the equation using our algebra skills into y equals mx plus b, and then start at this point and count the slope. Would you rather do that? Okay, we can do that. So 3y is equal to negative 2x plus 3, and y is equal to negative 2/3 x plus 1. There's that y-intercept of 1, which I kind of already knew. And then from that 1, I'm going to go down 2 and over 1, 2, 3, right? Here, I'll do it again even. Down 2 and over 1, 2, 3. There we go. 3 points in a row. You really only need 2 to make a line, but now it's an extra super cool line. And we're going to draw a line through it. I'm trying to be fairly accurate. Did that work? No. Oh, that's because I touched the screen funny. There we go. Let's try that again. Round. There we go. Okay, now I can already see that despite using a ruler and trying my very hardest, I tried so hard, I still kind of missed. That point's off a little bit. Accuracy kind of matters if I'm using a graph to try to find where 2 equations have the same xy coordinate, right? So let's see if we get the right answer. Okay, I'm going to do the other line in a different color. Oh, purple sounds fun. Let's use purple. So x minus y equals 4. This is a very easy one to do by intercepts, right? When x is 0, y is negative 4, and when y is 0, x is 4. So 0 over 4 down, and 4 over 0 up. Now we graph the lines. Oh, I think, you know what? I think I can make that go away. There we go. There we go. Oh, hang on. Didn't work. There we go. Well, what do you think? Does anybody's graph turn out a little more accurately than mine? And the solution to this system is 3, negative 1. Does it hit right on 3, negative 1? See, mine's off a little. Can you kind of, here, let me zoom in. There. You can zoom in a little and see that mine's off a bit because, again, there's only so much I can do drawing on this tablet with my clumsy human hands. If I assume, if I assume that my solution, I'll do it back to black. My solution, black. There we go. If I assume my solution is this point right here, which I'm going to assume is exactly 3, negative 1, how could I check to see if I'm right? Yeah, I think I agree. We're going to definitely try to just make sure. We're going to verify by substitution. Go to the first equation. Let x be 3 and y be negative 1. So 2 times 3 plus 3 times negative 1. And this had better equal 3. If it doesn't equal 3 something, I'm off by a bit, and that's not exactly the right solution. So 6 minus 3 equals 3. Well, that's a true statement. So we're 1 for 2. That works. But you do have to try both equations. The other equation is x minus y equals 4. So x is 3, Now careful, this is such an easy thing to goof up. It's x minus y, so I'm minusing the y value. I think we had this conversation the other day, didn't we? Be careful with minusing negatives. And yes, 4 does equal 4, it works. I stand by my solution. Even though it was a little inaccurate in the way I drew it, we have the right point. All right, if you count the ones that we did the other day, and this one, you've seen me do this 3 times now, your turn. See if you can come up with the point where the solution is. And I have a question. What do you got? Well, the solution is the point where they meet. So I actually just read that coordinate, right? 3, comma, -1. And that's what we're looking for. So your turn now. Graph the 2 lines and find the coordinates where they meet. And I'll catch up to you in a minute while you're doing that. While you're giving it a try, I will take attendance. So first we'll take attendance for the people at home. Whoops. And there we go. Download attendance list. And then we'll do the attendance for the people in the room. Idsby. Oh, Idsby logged itself out on me. What slots you spare? 2?
Yeah.
So on Wednesday, come here, something. That way, unless you'd rather do it at lunch. Okay, then lunch?
Yeah.
Lunch works better? Okay. So she's coming at lunch? How about you? Lunch? You don't have any spares in your day that you'd rather burn? Okay.
Is it at the beginning of lunch?
Yeah, you can eat while you work. Bring your lunch, we'll clean off the desk for you, and you can munch away while you work. That works. And then I can give them back to everybody Thursday, Friday. That's good. Okay. Okay, let me try to catch up to you now. 2x. Here's another one where x's coefficient and y's coefficient are both factors of 6. So I know that if I do intercepts, I will get whole numbers. So when x is 0, y is 6. When y is 0, x is 3. So 0 over 6 up. And 3 over none up.
Mr. Kelly?
What's up?
How do you get the points?
By realizing that if this x is 0, here I'll go through it more formally here. Remember, the intercepts happen, the x-intercept happens when y is 0, and the y-intercept happens when x is 0. That's where they cross the axes. So I can find this one. When x is 0, I basically just do algebra. 2 times 0 is nothing, so there it is. The equation's solved. That's where I get this 6 from. And then to get the x-intercept, I set y to 0. So 2 times x plus 0 makes 6. So 2x would equal 6, and x would equal 3. So that's where I got this 3 from. So basically, I just did these calculations kind of in my head, because they're fairly easy to do. And that's where I got those points from. And then I'm going to do the same thing for the next one. Only this one doesn't even need this much work, because look, if x is 0, y is 4. If y is 0, x is 4. So I have 0, 4, and 4, 0. So 0, 4. Oh, actually, that's the 4, 0. 0, 4, and 4, 0. And this one's going to be harder because these two lines, I don't know, let's see. What do you think? You get that they cross right at 2, 2? I'm off a little bit. But okay, I'm going to guess 2, 2. Let's see. So my solution, my tentative solution, is that they cross at 2, 2. Let's see. Let's do a check and see if that's right. When x is 2 and y is 2, do I get the right answer? 2 times 2 plus 2 is 6. 4 plus 2 is 6. Yeah, that one works. Does the other equation work? Does 2 plus 2 equal 4? Yep. Yep. So there we go. My diagram is definitely off. It should have been 2, 2. When that happens, make a bigger dot. There we go. There. See, look at that. They cross right in the dot. How about that? I call that the big dot theorem. When your graph's a little inaccurate, make bigger dots. You go through them every time. All right, so there we go. That's example 4, and that is what we call the graphing technique, the graphing method. And I'm not going to even give you a whole lot of homework on this because we did a whole unit of graphing last unit, and this gets a little tedious. So I think, assigned like 3 or 4 questions here. I think I already put it on the blog. But you know what I actually would like to do is I actually like to maybe kind of work ahead a little and get started a bit on 7.4, because as you can probably guess, there is an algebra way to do this without having to graph. So let's give 7.4 a bit of a start, kind of like we did with 7.2, where we did the first couple examples, then we continued the next day. So we're going to do that again. So we're going to solve this system by what's called substitution. And substitution is kind of one of the algebra techniques we're going to use here. And it works like this. I look at this equation here, x plus 2y equals 2. And I can use my algebra skills to rearrange it. I can minus 2y from both sides of the equation. And I would get the same equation, just written slightly differently. And now I'm going to substitute this expression for x into the other equation. So the other equation up here, 3x plus 4y equals negative 4. Instead of saying x, I know that x is equal to 2 minus 2y. So I'm going to replace the x with 2 minus 2y. And now that's basic grade 9 algebra, right? You got to deal with a distributive property, collect like terms, all that kind of stuff. So step 1, we do the distributive property. 3 times 2 is 6. 3 times negative 2 is negative 6. I'll collect my like terms. Negative 6y's plus 4y's is negative 2y's. I'll minus 6 from both sides of the equation, giving me negative 10. And I'll divide both sides of the equation by negative 2 for my final step. Y is 5. So there we go. Y is equal to 5. But obviously, the solution is an x comma y, right? The point where those two things meet. So I only have half of my answer. I have the y answer. I need the x answer. Well, look what I have up here. I have x equals 2 minus 2y. So if I know y is 5, I substitute again. So I'm gonna draw another arrow. And substitute back. And then that's 2 minus 2, and instead of y, I know y is 5. So x is equal to 2 minus 10. X is equal to negative 8. So there it is. The actual solution is -8, 5. Now, there's not much point in verifying on this equation because I kind of already did that. I just plugged the y number in. But I could verify back in the first equation. I could do a quick check, use the other equation that you didn't use on your last step, and see if you do get the right answer when x is -8 and y is 5. 3 times -8 plus 4 times 5 has to equal -4, or else we've done something wrong. 3 times -8 is -24. 4 times 5 is 20. And yep, that's a true statement. I think we have the right answer. So what do you think? Is that less work than graphing it and hoping that your lines land nicely on the point -8, 5? We have a question.
Do we always have to check?
Do you always have to check? If I tell you in a test question, then we want to see it. But if we don't tell you, it's kind of your call. Obviously, if I'm doing a big test and I'm in a hurry, I might not have time to check all my answers, right? But if it asks for it, you should be able to show it to me. So you should know how to do it. Okay? All right. We'll give you one more, and then we'll let you work on today's homework. People could be hopefully somewhat homework free here. And then we'll save the last example till tomorrow, just like we did for today's lesson. So solve this by substitution. Okay, how do you want to substitute this time? Okay, I see again that x is already kind of all by its lonesome. It only has a coefficient of 1. So I'm going to rearrange this guy into x equals 35 minus 5y. And then I'm going to substitute that x value into this x value. So instead of 4 times x, it's 4 times what I know x is, which is 35 minus 5y. And then I now have an equation that only has one variable, which makes me happy because I know how to solve that. You should be writing stuff down. Okay, so now the numbers get a little big here. 4 35s. 4 30s is 120 plus another 120, 140. Somebody double check my mental math. Minus 20 plus 2y is equal to 32. All right, so the negative 20y's plus 2y's is negative 18y's. And then I'm going to have to minus 140 from both sides. And 32 minus 140 would be negative 108. Now, you know what? I know that 108 actually divides by 18. You know how I know that? Because I know 18 is 9 times 2, and that's even, so it divides by 2. And how did I know right away that it divides by 9? Anybody remember the trick for looking at a number and quickly telling that 9 goes into it?
You add the things.
Right, I added the digits. 1 plus 0 plus 8 is 9. So does 9 go into 9? Yes, then it goes into 108. So I know that 18 goes into here. So I just have to skip count by 18s. That shouldn't be so hard. 18, 36, that's 2. 54, that's 3. Oh, so 6 of them, because 54 doubled. So 6. And the negatives cancel, right, because I'm dividing a negative by a negative. So there we go, 6. There we go. And of course, again, that's only half my answer. Right? That's the y coordinate of my answer. My x coordinate I can find by saying, well, if x is 35 minus 5y, I just figured out that y is 6 when these two lines meet. And x is equal to 35 minus 30, which is 5. So therefore, my solution is the point x is 5 and y is 6. And that's where those two lines meet. And again, I could do a check if you wanted me to, but I think we got it. Okay? I'll stop there for today. Again, today's homework won't have any of these. We'll do a couple more examples of these tomorrow before I turn you loose on this algebra stuff. Today it's kind of fairly easy stuff. You just get to graph some more. So here's the actual assignment. It's page... oh, here we go. Oh, you know what? I was asking you earlier if you had any problems on this. This is today's assignment. I should have been asking if anybody had got stuck on page 401. That's what I assigned for the weekend. There you go. Anybody who needs help with these, you can ask me in a minute. But here's today's assignment. It's 409, 345. I know there's some A, B, C parts, but still, it's probably less than 10 questions of homework. Okay? All right, I'm gonna stop my video.